Welcome to all of you. In this lecture, we are going to discuss about the linear convolution. Linear convolution can be obtained by three methods. First one, time domain formula based method. Second one, linear convolution using circular convolution. And the third method is the frequency domain method. In this particular presentation, we are going to discuss the linear convolution by this first method, that is time domain formula based method. Now the formula for the linear convolution in time domain is given by y of m is equal to summation n running from minus infinity to plus infinity x of n h of m minus n for all the values of m ranging from minus infinity to plus infinity. Within this formula, the x of n is going to indicate the input sequence, h of n is going to indicate the impulse response of the system, then y of m is the convolved sequence, m and n are going to be the sequence indicators. Now let us go through the various steps involved in the solving of linear convolution in time domain method. So given the sequences x of n and h of n, that means the input and the impulse response of the system will be given. Then after step 1, calculate the output sequence length. Capital letter N is equal to length of x of n plus length of h of n minus 1. Step 2, identify the starting index of x of n, that is given by x underscore si, where si stands with the starting index, and starting index of h of n, that is h underscore si. Step 3, identify the ending index of x of n, given by x underscore ei, where this ei stands with the ending index, and ending index of h of n given by h underscore ei. Identify the lower limit of the summation. So in the time domain formula, we are having the summation representation on the right hand side. We need to identify from where that summation has to start and where it has to end. That starting value, that is the lower limit, is identified by using this representation, that is x underscore si plus h underscore si. This is going to be the starting point for the summation. Similarly, the ending point or the upper limit of the summation is given by x underscore ei plus h underscore ei. Step 6. Calculate output sequence y of m at each value of m ranging from x underscore si plus h underscore si up to x underscore ei plus h underscore ei. That means between the lower limit and the upper limit, we are going to, at each value, we are going to calculate the value of m. Finally, the output sequence must have the length capital letter N. Now let us go through a problem where we can clearly understand these steps. The problem statement: find the linear convolution of the sequence x of n is equal to 1, 2, 3 and system having the impulse response h of n is equal to 1, 3, 6. Now within the problem, representing the origin in both x of n as well as h of n is very much important. Therefore, the one which is mentioned with the arrow mark or with this blue color, that is going to indicate the origin. So in the first sequence x of n, the value 1 is the origin, and in the sequence h of n, again 1 is going to indicate the origin. Getting into the solution. Identify the length of each of the given sequences. So that is length of x of n, that is equal to 3. So total there are 3 values. Therefore length of the x of n is 3. Similarly in h of n there are 3 values, therefore length of h of n is equal to 3. Now getting into the step-by-step process solution of the linear convolution. So in the step 1, calculate the output sequence length. It is given by n is equal to length of x of n plus length of h of n minus 1. So that is given by length of x of n is 3, length of h of n is 3 minus 1. So we are going to get 5. So output sequence will have the length 5. Next step. Identify the starting index of x of n, that is x underscore si, and starting index of h of n, that is h underscore si. Now within this given sequence, starting index in the sense what is the position of the very first element present in that particular sequence. Let us consider, for example, x of n. In this x of n, this 1 is going to be the very first element. And what is the position of this 1 that we have to identify? That is nothing but the starting index. So in this particular case, this first value itself is going to be the origin. Therefore, its position is equal to 0. Remember, the first element itself is the origin in the x of n. Therefore, the position of this value 1 is going to be 0. The position is 0. Therefore, the starting index is equal to 0. So x underscore si is equal to 0. Then what about h of n? In h of n also we are going to have the same criteria. Therefore, the starting index in case of h of n is also equal to 0. Next step, identify the ending index of x of n and ending index of h of n. Ending index in the sense we have to consider the very last element in the given sequence and identify its position. That is nothing but the ending index. With respect to x of n, if we consider the value 3 is going to be the last value. Identify the position of the value 3. It is 0, 1 and 2. Position is 2. At position 2, the value is 3. This is the last value. Therefore, the position of the last value is known as the ending index. In case of x of n, it is equal to 2, indicated by x underscore ei. The case of h of n also similar, because here also 3 elements, here also 3 elements. The origin in both of these two remains in the same location. Therefore, with respect to h of n also, the ending index remains as 2. Therefore, h underscore ei is equal to 2. Now, the next step, identify the lower limit of the summation. So that means from where the summation has to start from, that is the lower limit. So that is given by x underscore si plus h underscore si. So both of these two values are 0 that we identified previously. So those values are substituted, that will be equal to 0. Therefore, the summation has to start from 0. Now, which is the ending point of the summation? That is what the step 5. Identify the upper limit of the summation given by x underscore ei plus h underscore ei. So these are identified previously and they are equal to 2. Therefore, 2 plus 2 is equal to 4. So summation upper limit is going to be 4. Now, step 6 is the calculation part. Calculate the output sequence y of m for each value of m ranging from 0 to 4 in this case. So writing the formula for that. So usually we used to have an infinite representation with respect to the summation, but here we are going to have the finite length. Therefore, the summation is going to have a different values. Now, y of m will be equal to summation n is equal to 0 to 4 x of n h of m minus n. M is also going to take the same range, that is from 0 to 4. For each value of m, we are going to calculate one value of linearly convolved sequence. Now let us go through that. So at each value of m we need to calculate. At m is equal to 0, y of 0 is equal to summation n is equal to 0 to 4 x of n, h of in place of m substituted as 0 minus n. Now expand this summation. So after expanding this summation, this is what we are going to get. Right? So after resolving the h of representation, this is what we are going to get. So 0 minus 0 is 0, then h of 0 minus 1 is minus 1, h of 0 minus 2 is minus 2. So like that we are going to get this sequence. Now within this sequence, we must identify few things. So all the values of these positions are not available for us in the sequence x of n and h of n. For example, let us have detailed discussion. So x of 0 into h of 0. Both x of 0 and h of 0 are available for us. So this is x of 0, this is h of 0. So value 1 and 1 is substituted. What about next one? X of 1 into h of minus 1. So x of 1 is available for us. The value is 2 for that. What about h of minus 1? H of minus 1 is not available. 0 is for the minimum position we are going to have. So before that minus 1 is not at all available. In such cases, in those positions, we substitute the value as 0. Therefore, h of minus 1 will be equal to 0. 0 multiplied with this value is also equal to 0. Similarly, h of minus 2 is not available. So we consider this term as 0. H of minus 3 not available. It is 0. H of minus 4 is also not available. So we consider that as 0. 0 multiplied with any value, that is again 0. Therefore, all these values are going to be 0. So for calculation in this particular m is equal to 0, we are available with only the values of x of 0 and h of 0, and all other are going to be 0. So that's why it is represented in one color and all remaining in another color. So by resolving this, we get y of 0 is equal to 1. Then getting into the next one, at m is equal to 1. Y of 1 will be equal to summation n is equal to 0 to 4 x of n h of 1 minus n. Now expand this summation. We are going to get y of 1 is equal to x of 0 h of 1 minus 0 plus x of 1 h of 1 minus 1 x of 2 h of 1 minus 2. So similarly up to x of 4 h of 1 minus 4 we are going to get. Simplify the values within this bracket. So we are going to get x of 0 h of 1 plus x of 1 h of 0, then x of 2 h of minus 1, x of 3 h of minus 2 plus x of 4 h of minus 3. Now with respect to this, x of 0 h of 1 available for us. X of 0 is equal to 1 and h of 1 is equal to 3. So that is substituted here. Plus x of 1 is equal to 2 written over here. Then h of 0 is equal to 1. So that is also written here. So that we can multiply. Further, x of 2 I can get the value that is equal to 3. H of minus 1, it is not there in the sequence at all. Therefore, h of minus 1 will become equal to 0, 0 multiplied with something else that is also equal to 0. Similarly, it happens for h of minus 2 and h of minus 3. Therefore, all remaining three values are equal to 0. Now, simplifying for this, we get y of 1 is equal to 5. Further calculating for m is equal to 2, we are going to get y of 2 is equal to 15, and here we can observe there is an upgradation of one additional value calculation that you can observe over here. The color realizations you can identify. It is 15. At m is equal to 3, it is equal to 21. At m is equal to 4, it is going to be 18. So all values y of m is equal to 1, 5, 15, 21 and 18. So as per our identification, what must be the output sequence length? Output sequence length must be equal to 5. So there are totally 5 values present here. So 1, 2, 3, 4, 5 values are present. Now once we got the output, we must represent in the output also which is the origin. That is the most important thing. So in order to identify the origin in the output sequence, we are going to make use of this formula. That means identify the position of very first element in the output also. That is given by x underscore si plus h underscore si, that is equal to, in this particular case, both these values are equal to 0. So answer is 0. Therefore position of very first element is equal to 0. Therefore that itself is the origin. So that's why it is represented by the arrow mark. This arrow mark indicates the position of the origin. Thanks for joining.